Hello, Coach Holmes here, and today we're going to be talking about reflection. It's a different type of transformation as opposed to what we talked about yesterday with translation. Okay, but reflection is pretty simple in its own way. So, to start off, reflection uses a line to transform a figure and maps every point evenly. Okay, so here's what we mean. So say I have a line, and this is called, right here, this is called the line of reflection. Okay, it's called a line of reflection. Okay, it's called a line of reflection. So if I have this figure right here, and when I reflect it, it's going to be equal distance from each other. At least they should be equal distance from each other, or at least equal distance from the line of reflection. Okay? Not just from each other, but from the line of reflection. So if I'm like 2 units away from the line of reflection, then on the other side, it'll be 2 units away from the line of reflection. That's how a reflection is going to work. Okay? Now, there are a couple of transformation rules to remember when it comes to reflection. But these always seem to work. That's the thing about these transformation rules. They always work in this sort of way. So, when it comes to y-axis, xy goes to negative x, comma y. It always works that way. Now, for the x-axis, xy goes to x, comma, negative y. So really, when it comes to the x-axis, the y becomes negative, the x remains positive, because the x values isn't going to change. Just like in the y-axis, the x values is going to change to negative, but the y value isn't going to change. And then we have y equals x. That's a weird one, but it's pretty simple what the rule is. Just switch the y and the x. So instead of saying x, y, the value is going to be y, comma, x. So this doesn't mean, what this means is that I'm changing the value from negative right here, and I'm just switching the values right here. That's all it tells you. Without changing, we're not talking about changing how do we plot the point, but we're changing how we switch the points. We switch the values to get the new point. We're still doing x first and y second. We're just switching the values. And for the x and for the y-axis case, we're just changing the value. We're just changing the sign. Okay, so just to be aware, just to show you how it looks, okay? Just to show you how it looks. When it reflects across the y-axis, so this is my x value, this is my y values. That means I'm reflecting across this line right here. So I gotta determine how far away each point is from the line. But an easier way is to know that we just have to change the x values. We just have to make them negative. So for example, this is negative 2 right here. So instead of saying negative 2, I want to say positive 2. 1, 2, 3, 4. 1, 2, 3, 4. Because I know my y value here is 3, so I go up 3. But since it's a negative x, change my sign, it'll be a positive x. D is going to be 1, 2, 3, 4, 5, 6. Negative 6. 1, 2, 3, 4, 5. Now remember, it stays a positive 5, but I get a positive 6 because I changed the sign of my x. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And then for C, 1, 2, 3, 4. Negative 4. 1, 2, 3, 4, 5, 6, 7. Changing the value of my sign for x, which will be positive 4. 1, 2, 3, 4. Y stays the same. 1, 2, 3, 4, 5, 6, 7. And that's what a reflection is going to look like. Now, in this case, it does look like it's translated, but it is a reflection. It is reflecting. So let me give you another example of a good reflection. So I'm reflecting across the x-axis here. Okay? Now, again, I want to change the x value. I don't want to change the x values this time. I want to change my y's. So my y's happen to be 3. So I'm going to go down 3 from the line. 1, 2, 3. 1, 2, 3, 4, 5, 6. I want to go down 6. 1, 2, 3, 4, 5, 6. And another way to do it is by counting what I just did. Is by counting to the line of reflection and then count the same amount away from the line of reflection. So 1, 2, 3. So that means I'm going to count 3 away. 1, 2, 3. And see, that's a good reflection because while this is pointing up, this is pointing down. So that's what this is what a reflection is really going to look like. This is a reflection, but you can, well, this is a good reflection because notice how D is on the other side. So it is still a reflection, but without the letters, you can sort of tell that, well, it may be just a translation. Just think about the points, though. Next, we have a reflection of y equals x. What that means is this reflection right here. So I'm going to reflect across this line right here. Okay? I'm reflecting across that line. Now you would say, well, can we just count from the line reflection, the line reflection of the line, of the line of reflection? You can, but it's kind of tricky to how to count that because you have to count it at an angle. It'll be kind of weird. But remember, I just got to switch the x and y values. So for example, and I'll write it down here. If point A was -1, 3, that means I change it to 3, -1. So I'm going to go 1, 2, 3, 1. So for B, that's 1, 2, 3, 4. Wait, I'm sorry, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. So 3, 7. That means I'm making it 7, 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. And then point C is -1, 1, 2, 3, 4, 5, 6, 7. -1, 7. Now remember, I switched the two values, so I get 7, -1. 1, 2, 3, 4, 5, 6, 7, 1. Going down. So then I just draw my figure, and I got a reflection across the y equals x. Okay? So again, knowing your reflection rules is going to help you be able to determine where it's going to be. Okay? It's really going to help you to determine how you're going to reflect it. Because again, you could count from the line of reflection, but knowing that all I got to do for the y-axis, I change the sign for x. For the x-axis, change the sign for y. And for y equals x, excuse me, I just switch the x and the y values. Okay? Now, there is a thing called line of symmetry, which basically means how something can actually be folded evenly. And so, different figures have so many different lines of symmetry. But there are some figures that don't actually have a line of symmetry. So for example, if I look at this figure right here, I can look at it and say, that folds evenly in half. That folds evenly in half. Okay? So really, I have at least two lines of symmetry for this hexagon, for this stretched out hexagon. Now for this octagon, if you guys don't see it, I want y'all to pretend that it's all equal sides, okay? So not only do I have lines of symmetry going left to right or up and down, but I also have some diagonals and also some in the corner here. So I have about 1, 2, 3, 4, 5, 6, 7, 8, 9, at least 9 lines of symmetry. That's quite a bit. Or at least, isn't it? No, 8. 8 lines of symmetry. Yeah, 8 lines of symmetry, not 9. I miscounted. Or at least I counted this line twice. So we have at least 8 lines of symmetry. Okay? So it can be folded evenly 8 different times. Now for this right here, if I fold this way, we have this part leaning out like this. And what we mean by folding evenly, it's almost like it maps it. Okay? If I would, like for example, if I were to fold my hands together like this, my hand will map and matches each other outlines. Okay? This one doesn't. However, I can actually fold this vertically, like that. I can fold it vertically. Now for this polygon, if I fold up the corners, I would actually have these two corners sticking out a little bit, almost like ears. So I can't cut it this way, and this way is just as bad. So really, this would have no lines of symmetry. No lines of symmetry. Now for the square here, I have these two lines up and down, but I also can fold it at an angle. I can fold it diagonally. I can fold it diagonally like this. In this case, I would actually have 4 lines of symmetry. Now, this triangle right here, there's not really a way to evenly. I can't go down like this. I can't do it from the angle, or at least possibly could, but it's kind of hard unless we actually try it ourselves. If these two angles were even, then yes, you can definitely could. But assuming that they're not, this one has no lines of symmetry as well. So what we got to remember is that with lines of symmetry, it's just folding something in half evenly. If you can't do it, then it's not a line of symmetry. And there are some figures that don't have lines of symmetry. But the biggest key I want y'all to remember is the reflection rules. I want y'all to remember, how do we do these reflection rules? Reflect across the y, change the sign for x. Reflect across the x-axis, change the sign for y. But when we reflect across y equals x, we just switch both x and y. Thank you and have a good day.